In example 5e, we are going to find the domain of h of x is equal to the square root of 6 minus 3x. So this is a square root function. The concern here is plugging in an x value and then simplifying underneath and ending up with a negative number under the square root sign. Okay, we cannot take the square root of a negative number, so we have to be careful about what we plug in for x. Okay, so the way you want to handle a square root function, okay, like I said, we're going to plug in for x, then you're going to simplify. Whatever results underneath needs to be positive or 0. Okay, because you can take the square root of a positive number and you can take the square root of 0. The square root of 0 is 0. Okay, what you don't want is once you simplify under the radical, you don't want a negative number. Okay, so this is what we do to ensure that you don't end up with a negative sign or negative number under the square root. You're going to take what's underneath, so take the quantity under the radical and set it greater than or equal to 0. Okay, so if we apply that logic here, we're going to take the quantity under the square root, which is 6 minus 3x, and we're going to set it greater than or equal to 0. Okay, that is ensuring that the quantity underneath, if it's greater than 0, that means it's positive, or if it's equal to 0, that's ensuring that what's underneath, can be 0. Okay, so we're just taking the quantity underneath, setting it greater than or equal to 0 to ensure we get a positive or 0 quantity under the square root. Okay, once we solve this inequality, this will give us the domain of this particular function. Okay, so it is definitely a different process than finding the domain of a function that involves a fraction. Okay, so let's go ahead and solve this inequality. This is a linear inequality. Inequality just means that you've got one of the inequality symbols. You've got greater than or equal to, you've got less than or equal to, or you've got greater than, or you've got less than. Okay, to solve a linear inequality, you're going to solve it pretty much like you would a linear equation. You want to get the variable, the x here, all by itself on one side. So I am going to start here, since the 6 is positive, I am going to start by subtracting 6 from both sides. Okay, so this is going to give me negative 3x is greater than or equal to negative 6. So I've almost got the x by itself. X is being multiplied by negative 3. Okay, so to undo that, I'm going to have to divide by negative 3. If I do it to the left side, I'm going to have to do it to the right side. Okay, so on the left, the negative 3's are going to cancel and leave us with x. And on the right, negative 6 divided by negative 3 is positive 2. Okay, so here's something you absolutely have to remember from your math past. Okay, when you have an inequality and you divide or multiply by a negative number, just like we did here, you have to flip the direction of the inequality symbol. Okay, so since we divided by negative 3 here, we have to flip. Instead of greater than or equal to, the inequality symbol is going to flip to less than or equal to. Okay, you've got to remember this. So I'm going to put this in star this for you. Okay, when you multiply or divide an inequality by a negative number, you must flip the direction of the inequality symbol. Okay, please, please, please remember this. Okay, it will come up from time to time this semester. Okay, so when you multiply or divide an inequality by a negative number, you have to flip the direction of the inequality symbol. Okay, all right, so this is actually the domain here. Okay, your x values that you plug in to h of x is equal to square root of 6 minus 3x, the x values that you're allowed to plug in here have to be less than or equal to 2. Okay, so this is written as an inequality. Okay, how do we write this in interval notation? Well, we're going to draw our number line. Okay, so if we do that here, let's draw our number line. Okay, so here it is. Okay, there aren't any real bad spots that we talked about here. We just kind of have to graph this out. The key x value here is 2, so I'm going to go ahead and put that on there. And x, you can actually plug in 2 because x can be less than or equal to 2. So we want to include 2 in the domain, so we're going to put a closed circle to include it. Okay, now if you read this inequality to yourself, it says your x values have to be less than or equal to 2. So which way am I going to shade? Okay, well, if you kind of look at a number line here, you look around 2, which way do you go, left or right? Which way do you have numbers that are less than 2? Well, that's going to be to the left. Okay, so every number less than 2 is going to be okay to plug in. Okay, anything bigger than 2, like 3 or 4, you can't plug in. All right, so this is the picture. It's going to help us write down the interval. Remember, walk along the number line from left to right. Okay, if you're starting out here, okay, you know, you could be at negative a billion. You're coming from negative infinity. Okay, and then you're walking until you get to 2. Okay, you can't go past 2. 2 is included because of that closed circle, so we're going to put a bracket. We always put a parentheses on positive or negative infinity. So this is how you write the domain here in interval notation. And again, this represents all real numbers less than or equal to 2. Okay, and you can kind of test yourself. You know, you can plug things into this function in part E just to kind of gauge whether or not you got this correct. So if we pick an x value that falls in this interval, so maybe I'll pick -6. Okay, if x is -6, let's try it out. Again, our function is h of x is equal to the square root of 6 minus 3x. Okay, plug it in. Okay, so h of -6 is going to be the square root of 6 minus 3. You're going to substitute -6 for x. This is going to tell us underneath, if we simplify, we're going to get 6. Negative times negative is positive. 3 times 6 is 18. Okay, so this is going to be the square root of 24. Okay, we don't know that off the top of our head. It's going to be some decimal. But the key here is we plugged in x equals -6, and we got a positive number under the square root once we simplified. So you do get a valid output. Okay, so -6 would be in the domain. Okay, however, if we pick something not in this interval, so say x equals 3, and we plug it in to the original function, h of 3 is going to be the square root of 6 minus 3 times 3. If we simplify, we're going to get the square root of 6 minus 9. That is the square root of -3. Okay, and that's bad. You end up with something negative under the square root, so you don't get a valid output. Okay, so the takeaway here for part E should be, how do I find the domain of a square root function? Okay, again, here's the key. You want to take the quantity underneath the square root and set it greater than or equal to 0. Solve, and that is your domain. Okay, but you've got to remember this little tidbit over here. If you do end up multiplying or dividing your inequality by a negative number, you have to flip the direction of the inequality symbol. Okay, all right, so there we go. Let's move on to part F. Okay, if you look at part F, the function is j of x is equal to the cubed root of 6 minus 3 times x. So this is extremely similar to part E. The only difference is now we're dealing with a cubed root as opposed to a square root. Okay, so let's think about this. Okay, does it matter that we have a cubed root instead of a square root? Well, remember, what's our issue with square roots? We're worried about plugging something in and then simplifying underneath the radical and ending up with a negative number underneath the square root, because you can't take the square root of a negative number. Okay, so we've talked about cubed roots already in this class. Okay, and we said the big difference between a square root and a cubed root is that you can have a negative number under a cubed root sign. You can take the cubed root of a negative number. So for example, we looked at earlier, we said, okay, if you had the cubed root of -8, what is that? It's -2, because if you do -2 times itself 3 times, you get -8. -2 times -2 is 4 times -2 is -8. So you can have a negative number under a cubed root. So our concern, the concern that we had for square roots, dissolves if we're dealing with a cubed root. Okay, if we plug in an x value and we simplify underneath the cubed root and we're left with a negative number, hey, it's okay. We can have a negative number under a cubed root. Okay, so that concern that we had for square roots is gone. We don't have that same concern with cubed roots. Okay, so what that means is there's nothing really that's going to get us in trouble. Okay, so the domain here is going to be all real numbers. Okay, and just remember that's from -infinity to +infinity. Okay, and this is going to be true of all cubed root functions. The domain is always going to be all real numbers. Okay, so I'll write that out here. The domain of a cube root function is always all real numbers, because you can take the cube root of a negative number. Okay, again, if you take an x value, you pop it into the cube root, what's underneath, you simplify, you end up with a negative, no biggie. You can take the cube root of that result. Okay, so domain of a cubed root function is always, always, always going to be all real numbers. Okay, if you flip back to page 6, okay, that is underneath, if you look under some functions whose domain is all real numbers, number 2, odd root functions, so like cubed root, fifth root, seventh root, the domain is always going to be all real numbers because we can take the odd root of a negative number. Okay, so all the odd roots, you're going to treat their domains similarly. Same thing for even roots. Okay, so if you go to the even roots, okay, things like square roots, fourth roots, sixth roots, finding those domains are going to be similar. You're just going to take the expression underneath the square root or the fourth root or the sixth root, whatever even radical you're dealing with, you're going to set that quantity greater than or equal to 0 and solve, and that result is your domain.